This movie is for Unit 10, Learning Target 6 on geometric probabilities. So we know that a probability of an event is the number of ways that event could occur or favorable outcomes over or divided by the number of possible or total outcomes. Recall that a probability can be expressed as a fraction, decimal, or percent. So the event to the total. We can use geometric models to represent probabilities, and that's what we're going to be leading up to. Probability and length. If we have point S is on AD, and it's chosen at random where it's located, the probability that S is on BC is the ratio of the length of BC to the length of AD. So that's where we've got BC over AD. Point K is on ST, it's chosen at random. What's the probability that point K lies on QR? So we're looking at the probability that K is on QR. And that means QR over the total, which is ST. The length of QR is 3. ST has a total length of 14 minus 2, which is 12, and this reduces to 1/4. So we're going to leave it as a fraction in this case. Down here, pause the movie, try this one on your own, and press play when you're finished. We're looking at the probability that H is on SR. So probability H is on SR is going to be SR over ST. SR has a length of 8 minus 2, 6. ST is 12. This is 1/2. Probability is 1/2. Same thing is true with area. When you're looking at the probability that something lands in a specific region, you look at the area of that region over the total area. And that's what we're going to do here. So we're on a coordinate grid. What is the probability that a point randomly placed on this rectangle will land in the shaded region? So the probability that we land in the shaded region is, that's the triangle. So we're looking at the probability of the triangle over the total. So to get the triangle, we know that a triangle is 1/2 base times height, where base and height are perpendicular. So I'm going to use this as the base, which is a base length of 3, and the height extends from here to here, which is 1, 2, 3, 4. So I know that it's 1/2, 3 times 4, which is 6, over. Now I got to get the total, which would be this entire length by this entire length. 1, 2, 3, 4, 5, 6, 7, 8 by 8. 8 and 8 are 64. So it's 6 over 64. We're going to reduce that. 3 over 32 is our fractional probability. Pause the movie, try this one on your own, press play when you're finished. All right, probability that we land in the shaded region is going to be the trapezoid over the rectangle, which would be the total. The trapezoid has 1, 2, 3, 4, that's a length of 4. This is the length of 7, and the height is 2. So the trapezoid is 1/2 height times 4 plus 7. So the area of the trapezoid is, let's see, that cancels 7, 11. So we get 11 over the rectangle, which will be 1, this gives me 7. That is 9, 7 times 9, 63. And that does not reduce. So that is the probability that it lands on the trapezoid. Pause the movie, try this one on your own, and press play when you're finished. All right, probability that we're in the shaded region is going to be the parallelogram over the rectangle. So the parallelogram is base times height. So that is going to be 5 times 3, which is 15. And then the rectangle is this length by this length. Let's see, I think that's 6 and 9, which gives me 54. And that reduces to 5/18. So 5/18. Pause this, try it on your own, press play when you're finished. So we've got the shaded region is between the circle and the square. So probability of the shaded region will be the shade over the square. Well, the square we know is 6 times 6. That's 36. But we got to get the shaded region. So to get the shaded region, we got to take the area of the square, subtract the area of the circle. So the area of the square is 6 times 6, 36, minus the area of the circle. Now the circle has a diameter of 6, so it has a radius of 3. And so it is pi r squared, so 3 squared, pi r squared is the area of a circle. 3 squared is 9, so I get 9 pi. So the area of the shaded region is 36 minus 9 pi. And let's calculate that. I mean, if we want to keep it exact, we could do this. 36 minus 9 pi, and that would be the exact. But let's calculate what that is. 36 minus 9 pi divided by 36. And keep in mind, when you type that in, you got to do parentheses. You get 0.214. So that's as a decimal what the probability of landing in the shaded region would be. And that's all for the movie. Thanks for watching.